Thank you, George, for those incredibly inspiring words. I also share Jim's admiration and really admire your leadership for really, I think, putting an item of great national importance, not just for energy, but for security, on the agenda. And I think your voice speaks volumes of the things that are necessary for us to go forward. And it's a great platform on which I can build a little bit of what do we actually do. How this optimism, which I think I share, needs to be put into action. And so what I hope to do this morning as maybe a bit of a teaser is to start with this notion of this insurance policy, as George suggests. It's one that actually pays dividends. I like that part of it. I think it's in our national interest, and we do need a little more of a burning platform sort of sense of urgency than we have. But let me just do a few things. I've titled my talk. Let me see if I'm up. Am I up and running? Yeah. Okay. Good. I've titled my talk "Outlook for Clean Energy in a 4D World." Now you all know about 3D, but this is 4D, and what I'd like to do is really set up this notion of how dynamic the environment is, kind of where we are, a little snapshot of the actual data that we can observe as to the nature and status of technology and deployment of clean energy types of technologies, and then a little bit more about how that translates into a future that can be very exciting. And so especially for the students out there, this is a wonderful time to be in energy, despite some of the things that you might hear about it. And it's a wonderful place to spend your professional career in doing some things that really make a difference. So let me start with the 4 Ds. Let me see if I can work this clicker. Here we go. So the 4 Ds are disruptive technologies, differentiated energy services, disintermediation of the value chain, and distributed resources. So I'll talk about each of these. I'll say a few words about each of them. I'll spend most of my time on the first and the last. I think there's where a lot of the work that we do at NREL, and I think in the R&D community, we're spending a lot of time. I'll mention the other two and just talk a little bit about how those trends are fitting in to the future. As Jim said, I was at the New York conference on finance. This is the Renewable Energy Finance Forum that ACOR has every year. And Ira Ehrenpreis, many of you know him here from the Bay Area, venture person who just announced a big $400 million new fund, and they did that yesterday, demonstrates, I think, that there's a tremendous amount of energy enthusiasm for where this sector is going. So I want to talk about that. Let me start with a little bit around the status. Where are we? So one thing I'll start with, I start every talk that I give with this slide. And this slide says, we are in the midst of a transformation of our energy system. And I'm going to use that term very broadly. And we really should not care what technologies get us there. This is a false debate or discussion about which technology is going to get you there. What we really care about is the attributes of the energy system. So on the left-hand side of this chart, you see the attributes of the present energy system. It is a highly regulated sector of this country. In fact, in most countries, it's highly regulated. And it was built on a premise that is no longer accurate, the premise of inexhaustible, plentiful, always cheap, abundant fossil fuels that didn't have either security or global implications and or environmental impacts, and we now know that those things are not true. This is we started on this process 100 years ago. The energy system we have today has served us well. It will not serve us as a sustainable element of the future. And on the right-hand side of this chart, you see all the attributes that we would aspire to. I don't think I find too many people who would disagree with these attributes of being diverse and affordable and stable and reliable and efficient and flexible and carbon-free and all of those things. Most people won't argue with those as the attributes of a future energy system. And as a technologist, as a researcher, we really shouldn't care how we get those. If we get those, that's success. That's a home run. So when we talk about all of the above types of technologies, this is what I mean by it. I'm not sure what others mean by it, but that's what I mean by it. Is it a system that has this set of attributes? Second thing I'll say about that is pace does matter. How quickly we get there does matter. I think we'll eventually get there. The question is, how long will it take, and what will we ultimately pay in terms of consequences if we don't move quickly enough? And the rest of the world and other countries are moving that. So let me just kind of go back to where are we? So if you just look at the end of 2014, which is only 6 months ago, and you look at the world electricity production, and most of energy is moving toward electricity as opposed to some of the other ways in which we use energy. About 23, almost 23% of our global electricity production comes from renewable energy, and most of that is hydro, and it's been in place for a long time. The new so-called non-hydro renewable energy components are growing, and that's the part that we'll spend most of my time on. Wind is about 3%. Globally. Solar is about 1%. There's some other things, geothermal and biopower, that are all part of that. If you look at this country, what you see is that, and on the left-hand side of this chart, no need to read the details here, is the energy demand in this country, consumption, on the left-hand side is just total energy usage, is flat. And that's true for all of the developed worlds. We have essentially there's no new demand. We are putting in new infrastructure because we have aging infrastructure, but the demand is pretty flat, and a lot of it has to do with the fact that we are improving our efficiency, all right? On the right-hand side of the chart is just the electricity part, the generation piece, and there you see the mix of our energy domestically, and what you see is the black part of the histogram there, the black bar, is actually coal. And what you're seeing is that natural gas and renewable energy are displacing coal. All right, even though the generation is relatively flat, what we're seeing is there's a greater fraction of our percent that's going to other types of fuel. The red, by the way, is nuclear. So going back to the renewable, and in this case, the non-hydro renewable part, again, that part that's almost 6%. In the U.S., this is how other countries are essentially starting to play in this particular part of the energy mix. You see China, first of all, they have 150-something gigawatts of deployment of renewable energy as of the end of last year. The U.S. is just over 100, so we're now in second place. Germany, who put obviously massive amounts of public policy in place to generate a market, is close behind. And then the other countries are starting to follow. This sector in the last 10 years, has invested over $2 trillion I mean, it's a real sector. It's happening, and there's lots of effort going on. And this is kind of the mix. The blue there is wind, the yellow is solar. In terms of the energy percent coming from, in this case, all renewables, which includes hydro, this is just in different parts of the world how much we get from that part of our energy production. So in the U.S., it's 13%. About half of that is hydro, and the other half is all the non-hydro renewables. Again, wind, primarily the big one, 4%, solar, 1%, biomass, biopower is about 1.5%, geothermal is about 0.5%. And you see in other parts of the country now, in parts of the world, similar sorts of percentages, and much of this is hydro, I will admit. But it is, in fact, low carbon or no carbon technology. What's interesting to me is the mix and how it's changing. So in this graph, what you see on the left-hand side is the new additions of new capacity, fossil fuels. Okay, so think oil, gas, and coal. That's on the left-hand side. On the right-hand side, the capacity additions, this is globally, of new energy that is essentially non-fossil. Okay, so this includes hydro, which is the top blue bar, and then wind, which is the bottom blue bar. And what you see is in 2013, the fraction of our new additions that came from the non-fossil renewables is now greater than the fraction of new additions in fossil fuels. Okay. And by the year 2020, it's about 50-50 right now. By the year 2020, the projections are that it'll be 2/3, 1/3, and going quickly to 3/4, 1/4. So you're seeing that the new additions are in the new technologies, not in the incumbent technologies. Now, it's interesting also to look at, and you don't need to read the details on some of these. This presentation will be made available to you so you can see all the details at your leisure. But the point I want to make in this graphic is that most of the new additions are coming in the developing world, not in the developed world. In the developed world, we do have additions of new capacity, but it's because we're changing aging infrastructure. In the developing world, in the emerging economies, they're building new infrastructure, and they're primarily going more green than not. In some cases, that's not the case. But in most cases, their mix is better than the global mix, even in the new additions, and that was kind of the key point. If you look at who's making those additions, the chart on the left has to do, the green is the Europe, the blue is North America, the red is Asia, primarily China. And what you see is a larger fraction of the investments are being made by Asia, okay? A smaller fraction by Europe and a middle fraction by North America. On the right-hand side, you see by technology. So the blue on this graph is by quarter the investments in wind. The yellow is the investments in solar. And what you can see is tremendous investments in solar, and it's continuing to increase. So the markets are responding to the opportunities out there. I also always show this particular slide because what it is it's the assessment. It's one of these things, and it's where George started earlier. Is let's kind of talk turkey here in terms of what is accurate and what isn't accurate. What is accurate is that there is plenty of resource. There is not a limitation, a technical potential of renewable energy in particular for meeting our future energy mix. That question has been answered. We have way more renewable resources available to us than is necessary to power our planet, okay? That is now, we've done numerous studies. I've been part of most of these. NREL's been part of all of them. The last study here is one, we call it the Renewable Electricity Futures Study. And I've got another graphic here, which actually is a simulation that came out of this study. It's a very, very complex, comprehensive evaluation. And what you see here is a simulation of the results that we got, which was, in the year 2050, if one wanted to, they could essentially supply 80% of the hour-by-hour demand of this country in the demand centers that we have from renewable energy. You could do that really at very little cost, and I might add, I think one of the things that I always talk about when I talk about the study is it didn't take new technology, it didn't take breakthroughs. You can get there. This is not a question of can you do it. You can definitely do it. The study was not a prediction or a projection. It was a scenario analysis. Can it be done? And the short answer is yes, it can be done with modest changes to transmission and some of those things. This study was done literally 4 years ago. The technologies and the assumptions that we put into the study didn't fully take advantage of all of the cost reductions we've seen. In fact, solar was essentially, we've had a 50% drop in solar that was not part of the study. So even in the context of these very conservative assumptions, the results are, and I would offer that I think in the future, if we put in the new movement in technology, the new movement in the way in which the market is forming, you can actually get there less expensively than you can get there today. I think if we redid the study today, that's the conclusions that we'd find. The point is, and we're not the only country doing this. In fact, we're part of a study right now, and China just came up with their renewable energy electricity future study, and in fact, what they found was 85% of their load can be met by renewable energy by the year 2040. So there is no more discussion about can it be done. The question is, how might you do it? And there's no substituting for the fact that the energy sector is a regulated sector. It's been regulated since the beginning. It still is regulated. Let's at least acknowledge that and then talk about what is our public policy that demands some new approach to the way we do it. And so this really is a partnership between technology, which is, again, going to make huge differences in the choices that we have, in the markets, which is about finance. When you're going to make $2 trillion of investment over the next 20 years in this country, $20 trillion globally, the question is, on what will you invest? And how can you give markets in this country and globally a fair return on investment. And you do that because there's actually policies that encourage that. So the policies of the early 1900s were that cheap energy was a good thing for this country, and we're going to build our industrial revolution, and we're going to build our economic prosperity on the basis of an infrastructure that is common and can raise all boats. And in this case, we still have that same aspiration. It's just a different environment. So our public policies should follow, which is why I endorse this notion that we do need an insurance policy that says we want to move in a particular direction. Let's set the rules in a way in which markets can work, and technology and innovation can create and be a wonderful part of the thing. So that's really what it's about. Mobilizing capital is really the key here. So it's a blend of technology, markets, and policy, and you simply can't get away from that. All right, so let me just go through now my 4Ds. So the first of those is disruptive technologies. A tremendous amount of activity going on. Many years ago, I was at Bell Labs and had the opportunity to move to Sandia Labs to start solar programs middle 1970s during the oil embargoes, and that's when the technology started to move. I was in the laboratory, working on solar technologies, as a young engineer, it was really exciting. Didn't realize how long it would take for that technology to actually take place. But what I have found, and these are a couple of graphics that we use at NREL, which I think are indicative of the progress. So the one on the left is all the material systems that relate to solar, in particular photovoltaics, the direct conversion of sunlight to electricity. And there you see different material systems. The point to take away from that particular slide is every line on there is up and to the right, and some of them are pretty steep. And there's all kinds of new technologies coming into place, and the things that we started 30 years ago when I was in the laboratory are today's commercial product. The things I see in our laboratory today are absolutely mind-blowing. They are so revolutionary, pales in comparison to anything that I had, or we had back when I was a researcher. The things that are going on in the laboratory today, not just at NREL, but in many places across the country, is phenomenal. On the right-hand side, as you see the equivalent of Moore's law. Some have labeled this Swanson's law for one of Stanford's illustrious professors. Essentially, you get a 20% reduction in the cost every time you have a doubling of the deployment. And these are module costs, and they're coming down dramatically. And the good news is they will continue to come down. I see no end in sight for these. Module cost was the last slide. This is actually system cost. I won't go into that in any detail, other than to say, as deployment increases, the costs keep coming down, and the markets are established, and it really is quite exciting. Now, the one thing I will say is that what we need, I remember I mentioned that photovoltaics is like 1% of our overall power generation. This number can be much greater according to those studies that we talked about. I mean, there's no reason why it can't be, 50%, some large number, right? But the technologies that got us to 1% are not the technologies that are going to get us to the terawatt scale that we need to go to. And here's where I'm excited as a researcher and as an engineer, is that there are tremendous new, developments happening in the laboratory. The interesting part about solar to electric conversion is that the real business end of this technology is in the first few monolayers, the first few layers of molecules and atoms that are arranged in some very unique way. And what you find is that what we've tried to do is that we've taken semiconductor technology and converted it to be, kind of module technology of today. But that's like driving the Model T when there are, essentially sports cars on the horizon, and ultimately we'll be taking, we'll be taking flight. There is no end in terms of how much progress can be made on the innovation front. So these are just a few of the things we're working on at NREL, and that's phenomenal to me because, frankly, the technology is moving much more quickly than anyone anticipated, and the more and more interest we get at the research level, the more innovation and creativity there is. So there is very little in terms of, I think, boundaries that I can see in terms of materials and material development and those kinds of things. I'll say a word about wind. Wind is huge in many different ways. We have big turbines that are now part of the landscape, and they're a big fraction of our base load these days, and that will continue. And we haven't even tapped offshore. Offshore, there's tremendous resources that simply haven't really been focused on. The other thing that I see in the laboratory, which is quite exciting, is everything that relates to biofuels. And we started with this notion of looking to try to find another substitute for liquid transportation fuels, because they're really, the transport sector is much harder than the electricity sector in a lot of different ways. But the challenge here was that we didn't really know much about what we could or couldn't do. And it's very interesting to me, because what I have found as the technology has progressed is that as we get into the details, we used to be very Edisonian, you know, looking at things from experimental. We're now going back to first principles and applying new techniques in the research community, and we're learning things that we never knew existed, and we're now finding how we can manipulate the environment around us in a very, very positive way so that we can get new options for, essentially in this case, biofuels. I will offer that biofuels is maybe the tip of the iceberg. There are bioproducts of all kinds, where you can actually take, you know, essentially biomaterials of all kinds, cellulosic materials, hydrogen, you know, carbon, oxygen kind of molecule chains, and create whole new products so that you are not just thinking about fuels, but you're thinking about lightweighting of carbon fiber materials for not only for turbines, but for automobiles and for a variety of other things that are going to really increase. So this area has given, I think, a lot of impetus to the notion of sustainability. And I think you'll see a lot more beyond just fuels, but actually bioproducts of all kinds. So a lot of things going on there. On the end-use side of our equation, and now I'll talk a little bit about transport, you know, there are all kinds of options. You know, there's certainly electrifying our mobility. That's an important thing. Another piece, of course, is, you know, you might go to fuel cells. I know some of our folks in the Bay Area are not crazy about fuel cells. On the other hand, these are options that I think people will pursue, as well as biofuels of all kinds and natural gas. I think there are ways in which we can diversify our transport system. And I think we've got several different options, and we shouldn't discount them too early. I think there's going to be a horse race here, and I think it really is something I'm quite excited about, because our system as it presently sits is incredibly inefficient. The opportunity space is huge because the assets that we've invested in, and certainly in generation, are less than 50% utilized. I don't know of a business model that I know of where you get much return on investment when your asset utilization is less than 50%. That's kind of a really bad model. And I think we can do much better than that. And so that's where I think we've got a lot of opportunity. A couple more things on our disruptive technology sector. Efficiency is such a low-hanging fruit. We've talked about it for years, and yet it seems to be one of the hardest ones for us to really get our arms around. It is so important that we start with making things a lot more efficient, and then we can talk about how we power to provide the gap between what we still need after we've made things efficient. I mean, you know, the one attribute of sunlight, which I particularly like, you know, in my personal life as well as my professional life, is that sunlight kind of the best source for lighting, you know. We end up not doing very much. We would end up building buildings and closing them all in and then burning coal so that we can generate electricity, so that we can plug in lights so that we can see in a building that ultimately, if we put in some windows, we could actually see better, right? So these are kind of nonsense sorts of approaches to you know, not having taking full advantage of energy efficiency. But there's a lot of technologies that we can apply, and on our campus at NREL, I'm very proud of the notion that one of the things that we're doing is starting to walk the talk. I mean, I live in a building that's literally got 1,350 people in it, and it's net zero energy. On an annual basis, it generates more energy. We've got 2.5 megawatts of solar panels on the roof. It generates more energy than we consume. And we have to be efficient in our use of energy, and so we do that. But there's ways to do that, and by the way, it costs less to build that building than a building built to code. It's not that it costs extra. It's just a matter of you start with the end in mind. And if you want to do it, you can. And I think that those principles are held elsewhere. I'll say one more thing about research and about disruptive technologies and why I'm so bullish. We have a new center at our laboratory called the Center for Inverse Design. Think about it as kind of technical jeopardy. So if you knew what the attributes of a material would be to be the best material for some particular application, you pick the application, photovoltaics, batteries, whatever it might be, and you knew what the attributes of it were, then you could start and work backwards and say, I know what the answer is. What's the question? What material would I use to do that? Now, we've done it the other way around. What we said, we look in nature and we say, what materials do we have and how can we best tailor them to the application? This is turning that approach around and saying, for the perfect application, I need these kinds of, for the perfect material, I need these kinds of attributes for them to fit that need. And so we've started with high-performance computing and a lot of predictive modeling and a lot of understanding of basic materials and started to ask those questions. And then we back up synthesized materials that we didn't otherwise think about or know about, and then ultimately test that to see if, in fact, we can get that. So this EFRC, it's an Energy Frontiers Research Center that the Office of Science at the Department of Energy funds, has been doing this, and we're starting to test this out. And so we do the theory, we do the characterization and synthesis, and then we do the test. We actually have some examples of how that has actually worked. And in this case, we're looking at a semiconductor material that could actually do water spitting. So it's kind of a hydrogen production of materials. And we kind of know that manganese oxide is it's kind of a metal oxide that kind of works for this process, but it's not ideal. Zinc oxide is another one that kind of works for this process, and it's not ideal. But if you put the two together, and you wouldn't think to do this just normally, but with our computer models, understanding the nature of both those materials and the phase changes and the structural changes that occur when you do alloy them, the computer predicts that it's some mix of these, there's actually going to be a more optimum material. And we actually did that. We went through and did a bunch of fancy diagnosis and ultimately proved that you could do a 50-50 mix where the phase changes, and we wouldn't have otherwise found this particular capability or technology. That is, in fact, the new way in which research is being done. Now, I got my degree here at Stanford, and I was blessed with having a thesis committee made up of two of the legends at Stanford, Dean Bill Kays, who was a theorist, and Lou London, who was an experimentalist. And I was the student, and what I found was that both wanted all theory or all experimentation, and so they made me do both. And so I had to go through the process of that exercise. What it did was it gave me a better understanding of the way in which theory and experimentation come together. And in today's environment, we don't do experiments the way we used to do them. We do the theory, we do basic modeling and understanding based on first principles, and then we do targeted experiments to validate the models and improve the models. That's how we do research. It's kind of what we're seeing in this inverse design center, and for the most part, what you're seeing is a new way, a quicker and faster way to do research, more productive, using the tools of today as opposed to the way that we used to do things. It's an exciting time for developing a whole new class of technologies, research materials. There's a renaissance going on in the laboratory. That's why I'm bullish about the fact that disruptive technologies will continue, because we've got new tools that we never had before, and we're gaining new insights we never knew before. And at the micro scale, at the nano scale, the physics changes. And when the physics changes, new opportunities arise. So it's a great time to be in the research field. Now, let me say a word about the three Ds. So this one is differentiated energy services. You know, it doesn't take too much analysis to figure out that it's really not about the electrons. The electrons are not what we care about, right? We care about the services that the electrons enable. And what we really care about are things like shelter and comfort, and safety and security, and mobility, and information access. And you can divide the services in different ways. But when you do that and you say, okay, now, if I want that service, and lighting was a perfect example of it, I may not need electrons to get lighting, right? I may find that a different way to get my lighting than doing electrons. So one of the things that we've done at NREL is we did what I call a Vision 2025 study. And we did an exercise primarily because, I said, think back 10 years. So 10 years ago, 2005, and ask yourself, what would you have projected in 2015? Would you have got it right? And the answer was no. We would have missed a lot of stuff. We would have missed the recession. We would have missed natural gas, as the unconventional development of those resources. We would have missed a lot of stuff. And the question is, in 2015, if you want to look to 2025, what does that look like? And so it kind of expanded our thinking, and we wanted to look at it through the lens of energy services, not just technologies. And then we said, so what are the technologies that will enable each of these energy services? And on this graphic, you see some of those. And this is really what we care about. We care about the services that energy provides, not necessarily the electrons. And that gives rise to a whole new thought process on how we deploy our energy system. And that really, really is important. I could say a lot more on that. In the interest of time, I won't. The next big thought is this disintermediation. And some of my folks at NREL said, what does that mean? Well, if you look at it, disintermediation is happening everywhere in all sectors, not just in the energy sector, but it's essentially eliminating the middleman. It's really, instead of these vertically integrated silos where the value and supply chain is really captive in one particular area, we now open that up to a lot of different places. And what's enabling this, of course, is the IT revolution. And there's lots of things that are really quite, I think, dramatic in that case. So one of the things we're doing at the laboratory is doing the analysis on, and I always get a lot of criticism from many of the people in the legislature in Washington, because they say, you know, if we put all this money into research, how do we know we're going to get the benefit back from it? Well, you know, other than the fact that it's, you know, for me, I think it was kind of self-evident, but not always to some of our elected officials. So they want to know, you know, how are we going to ensure that the U.S. is going to benefit? It used to be, you could do great research, throw it over the wall, great things happen, because most of the infrastructure and the supply and where the value was created was in this country. That is no longer the case. It's a global economy. So what you have to think about is, where is it that we have competitive advantage? And so you have to do the analysis. So I know batteries are a big thing right now. This is a couple of things that we've got in terms of where we might go. And the fact is, it informs our research investments, but it also informs our elected and otherwise decision makers, investors and regulators and others who are providing input into the formation and the direction of where our energy system will go. So don't expect you to read these, but what the top one is the techno-economic analysis of how you build a lithium-ion battery. So you go back and you look at the process steps. You look at what information do you need, what materials do you need, what process do you need, what's the cheapest way you can build those, what does that technology ultimately allow you in terms of costs? And you build in all the margins, build in all the CapEx, build in all of the things that are necessary to make that a business that's viable on a global scale, at the terawatt scale, at the massive scale. You think about that system, and then the bottom graphic is how are those essentially trade flows go? In what parts of the country? Right now, 80% of the lithium-ion battery market is in Asia. And you know, there's big announcements here in the U.S. about providers of that technology. You know, our analysis says this is a tough business. This is really a tough business to be in. Now, that's not to say that there's not opportunity. In fact, our analysis suggests there is opportunity, and location is not as important in terms of where you site your manufacturing, but the ecosystem that goes around it is very important. There's a bunch of suppliers of various technologies and all those kinds of things. This is where this disintermediation thing comes in. You can either captively have that vertically, or you can look more broadly and say, who's going to provide what and on what basis, and how do I know I'm going to make value out of that and otherwise have a great deal of opportunity. All right, the last D is distributed resources. I'll spend most of my time here because, frankly, distributed resources is, in fact, a game changer. It's a game changer because technology is offering us new opportunities, and we have these two sets of the investments being made. There's the developed world that's making investments in terms of improving and otherwise replacing aging infrastructure, and there's the developing world where you have clean slate and you get to do things new. So there's opportunities for leapfrogs and those kinds of things, right? So this distributed meets central generation is kind of an interesting debate, and they always say, well, which one's better? The fact of the matter is, it depends on the region you're in, and depends on the maturity of technology. It depends on the variety of other factors that are really important. If you look very precisely at how do you get to a distributed resource sort of environment, you know, the one thing, and this is, you know, again, for us, for those of us that have been working in the renewable energy field and energy efficiency field, this is, you know, this is about integration and scale. You know, at the 1% and the 5%, you know, I don't think we're ready to declare victory. At this point, it's great that we're at the table and we actually have a part of the package. Now it's a matter of how do we get to these bigger numbers that I know exist? Well, it has to do with, in fact, taking advantage of the intelligence and taking advantage of the trends that we know are out there. So variable supply, you know, it used to be that variable supply was like, oh my gosh, how do we deal with variable supply? We know how to deal with variable load. We've been doing that for a long time. How do we deal with variable supply? Well, you know, it is a matter of will to do it. You've got to change what we're doing. Our system today is not very intelligent, and we can do this much, much better. And so here are some of the attributes: variable supply, increased distribution, in fact, bigger cooperation between regions and sectors, and then probably the most important one, the role of the consumer. We are no longer passive consumers. We like to be part of the deal. I like to think we call ourselves prosumers now, producers and consumers, so that you have choice. You have things you can do that you didn't otherwise know how to do. So I'm going to fast forward through some of these. I think the thing really we want to do is recognize that there is a way to not only include variable supply, variable load, at the same time there are ways in which we can improve the system that improves reliability and resilience and affordability and asset utilization, and that really has to do with having a much more intelligent system. We need to be able to flow electrons in two directions, not just in one, from the big power plant all the way out to the wall where you actually take the energy. You need to be able to generate your own, use some of that when you need it, plug some back in, provide a set of services back to the grid that might be valuable. Voltage and reactive power regulation can be supplied by renewable resources in a distributed way. We're actually doing those experiments right now at our laboratory. The equipment is not there yet, and most of the incumbents that are in the market that we have today are looking and asking the question, I don't think I want to make that sort of experiment on my system lest there be any concern about reliability and those kinds of things. I get that, and that's important. So what we need to do is really look at how can we de-risk the technology. What are the things that we need to do? Well, first of all, the IT revolution is not going away. Everything has got an IP address. Everything generates a tremendous amount of data. Everything is, in fact, providing us an opportunity to take that information and synthesize it and control things with it and offer new services with it. It allows us a new set of capabilities we never had before. And so all of a sudden we're beginning to attract all kinds of new partners, one of which is Google. Google is, as you would expect, these folks in Silicon Valley are very much forward-leaning, forward-focused on things that, this is not just about sustainability, this is about the things that will enable a new future. So Google is working with us on a new class of inverters. One success story that I particularly like, it happens to be one with Hawaii Electric and Solar City. Now Hawaii is a small, consider it kind of an island state, right? So it has small grids and they don't have a lot of choices. Until a few years ago, 97% of their electricity was generated from imported oil. Obviously, they don't have any oil there. So they said, well, and their electricity prices were somewhere between 35 and 40 cents a kilowatt hour, which is enormous. So they said, let's go green, and they started doing that. And they got to a point where the electric company said, gosh, this is really, you're putting so much solar on our system, this is really starting to be a hassle. And we're just going to have to clamp down, no more solar onto these distribution grids. They came to our lab, and what we did is we solved the problem together. And what we were able to find is that smart inverters actually can control where, the amount of solar resource that you can put onto these distribution grids. And we doubled, so that we went beyond where they were, and we said, okay, let's go through and figure out how can we make sure that the system is not going to be affected, and ultimately we can put a lot more solar on the system. So we found a nice solution that in fact has already commercial players in it, where if you add a new solar onto the grid in Hawaii and you put a smart inverter with it, which is not very expensive, then they'll let you put more. And it was a nice compromise between what Solar City wanted to do, which is more deployment, and what HECO wanted to do, which was to make sure that the system and the grid was compatible with the new technology. We have a new energy systems integration facility, and I apologize, you can't read this one, but I'm particularly excited by two things. One is the level of sophistication on the projects that we've got going on. There's $13 million of new projects, and the projects really have to do with how do you connect these devices into this environment at the megawatt scale, and in a way that does not decrease reliability. So you've got the partners coming in. At our new energy systems integration facility, George mentioned that we have industry partners. We have 6 utilities, EPRI, in a number of different ways. We have 70 private sector partners, 4 governments, you know, a number of universities, a dozen or so universities, and we're using all of the creative power of all of these institutions in a way that takes advantage of this virtual environment, high-performance computing and a variety of other things, to allow us to understand how do you connect devices? How do you do energy management at the distribution level, at the transmission level? How many devices can you put? How much solar can you put at the end of one of these microgrids? And all of these, what's the role of vehicle to grid? So we've got several things. We've got a partnership with Toyota. We've got a partnership with University of Delaware, where they're doing vehicle to grid types of research and looking at how do you use that as a storage mechanism. Lots of great stuff. So a couple more things I'll say. Efficiency. So the philanthropic organizations, Wells Fargo Foundation, has come to us and said, you know, we think efficiency is so important. We're willing to make investments, manage the program for us, develop new technologies. We'll use them on our system. And we've got a fairly major program with Wells Fargo where we're developing a bunch of technologies, and then they're applying them on their system and their, you know, their various distributed buildings all over the country, which is really, really exciting to me because we're bringing in a new set of players that are actually active in the sector without the government's, you know, direct involvement. So let me finish with concluding thoughts. And the first thing I'll say is we need to invent the future that we want. I mean, there is no question that the landscape is exciting. There is so much that can be done. There is a number of different potential futures. I don't know which one we're going to be on, but we need to have some desire to get there. And that's the part where I think we need more advocates. We need more George Shultz's saying the kinds of things that they say. We're cautiously optimistic that things can actually occur, but for our own willpower to make those happen. So I'll leave you with 2 more thoughts. The first one is, let's invest in research and innovation. There is no question that it's going to pay huge, huge dividends. The second is that the future that we aspire to is there for our taking. We have to put the policies and the financial things in place to get us there, but it's there for our taking. It is about the money. It's always about the money and the investment and return you get on those investments. It's a global issue, and you need to essentially partner on a global scale. This is in our national interest to see that this transformation occurs, not just in this country, but other countries. And at the same time, I think if we lead, we'll be competitively advantaged as a part of it. So the last thing I'll say is you know, I've been in this business now, gosh, close to 40 years, and I've always said, you know, gosh, we're almost there. It's you know, we just need the next big level. So I borrowed this slide from a friend of mine at Rice. And, you know, and this is kind of indicative of the renewable energy I think, community. You know, if you sit on the porch with the big dogs and occasionally you bark like a big dog, the world will perceive you as a big dog. And I think Renewables is at the place where we're a big dog, and we need to capture that and ultimately embrace that, because I think we're there. It's a matter of how do we make it bigger, and how do we go from here. So thank you. All right, we'll take some questions now.
Dan, I feel as though I have been drinking from a fire hose listening to you. But I was optimistic when I stopped talking, and then after listening to you, I'm over the moon optimistic. Yeah. So let me ask you a question. About 6 years ago, I put solar panels on my house here on campus. I've long since paid for them by what they've saved me. I drive an electric car. Doesn't use as much electricity as being generated. So my cost of fuel is 0. What's not to like? Now, my question is, you're talking about how much progress has been made on solar panels. Would it pay me to take the ones I've got off and put new ones on?
So the short answer is no, I wouldn't do that. What I would do is this, though. I think what you'll find that if you had a storage capacity, that you could actually get more value from those panels than you presently have. And let me tell you why. On a typical installation, and I have solar panels on my roof too, which took me 6 years to pay off. But here's what you find. The usage profile in a typical home has lots of peaks. And so the amount of energy that you generate is not constant. At night you don't generate. Sometimes when there's clouds or raining you don't generate. But you still have loads. And when you have those loads, you're borrowing, you're taking energy from the grid. And if you had a small storage, it doesn't have to be a big storage. If you had a small storage, what you could do is even out those peaks. And those peaks is, if you have certainly time of use pricing on your electricity bill, those peaks is where you get charged by the utilities for, you know, essentially usage. If you even out those peaks by having a little bit of storage, because
isn't this what Tesla is trying to peddle?
And this is exactly
so and things are coming.
Yeah, they are.
Anybody got a question? Got a couple of minutes here. Somebody's got a question. They have arranged to have us blinded, so I can't see.
There's a question over here. Yeah.
Wait for the mic.
Yeah. Maybe he'll hear better. Yeah. Oh, nice. We can see it.
Yes, I have a question. The utilities have great capabilities, know-how, knowledge, customers, billing systems, all of that for the grid, but they also have an old business model that potentially stands in the way of particularly distributed resources and exactly the things you're talking about. How do we get around that?
Well, so all utilities are not the same, and I'll be you know, quite acknowledging of the fact that there's a number of them that are very progressive and forward-thinking. And so I think in the utility arena, in the various board rooms, they're having these conversations as to what do we do, how do we do it, how do we deal with this new environment that's presenting itself. So you'll get everybody from, you know, the Tom Fannings at Southern Company who are saying, you know what, this is, we're gonna make some investments and we're gonna start offering our approach to solar services to the community. You know, in California and in Hawaii and in New York, public policy actually is driving the change. In some of the other states, it's not so much. And so the utility, the investor owns in particular, are looking at what are the dynamics, what are the drivers, how much urgency do we need. I think you'll find California utilities a lot more progressive than in other states, primarily because public policy demands it. And I think, so there is part of the answer, which is, you know, let's at least share the results. You know, when those who offer, you know, criticism say the sky is falling if you make these changes, and some people make the changes and the sky doesn't fall, then we need to share those experiences, right? So those things are going on. I'll be at NARUC in a couple of weeks with public utility commissioners sharing, you know, the stories, what's out there. I think most of what we see in terms of progress is grassroots. It's ground up. Local economic development driven primarily. But there is a lot of, I think, attention by the peer group saying what's going on in that region versus what's going on in that region. It's not uniform across the country. And there is a groundswell. I think, again, one more time, I would say now is not the time to relax, even though we've got low energy prices and we've got access to shale gas and we've got essentially, you know, a relief a little bit for the time being on oil prices. Now is not the time to relax. Now is the time to really invest. And that's kind of a hard message to get to people, but I think it's important. And as Secretary Schultz has mentioned several times, I mean, we do have some urgent matters that really require our attention. And one of those is, in fact, you know, carbon emissions. There's no question. The science is clear on that. It's not a matter of if, it's a matter of how do we deal with it. And that, of course, is a much more challenging environment.
But your question brings up how hard it is to get change to take place sometimes. Way back a long time ago, I used to teach at MIT. So all the engineers they want to change things. So I tried to teach them that it's difficult. You got to think about it. And I ran across an article by a man named Elting Morrison. He's from the Morrison family of Navy students, on the introduction of continuous aim firing into the US Navy. This is before World War I. The roll of the ship was such that they had to wait for the roll to be at just the right moment and they could fire. And somebody invented a way of keeping the guns trained so that they could fire no matter what the roll was. So it was continuous aim firing. And it was absolutely demonstrated unequivocally that it was far better from the standpoint of warfighting. But they couldn't get it to be introduced. Admiral Sims almost got court-martialed for pushing it so hard. Then World War I broke out. Bing, they changed right away. So it took a spur. I think sometimes it takes a little jolt, or maybe it takes a change in the atmosphere, that people don't change are dumb, people who do are smart, and you change the atmosphere that way. And that's beginning to happen, I think.
Yeah, absolutely. Absolutely. There's a question over here, sir.
Hi, John Massey. Can you address the trade-off between doing innovation and research and shipping things that already work to help the cost volume, manufacturing curves come down? I used to work at Bell Labs, and we used to worry about this stuff all the time. So can you talk about that in the energy industry? How much do you wait for the next breakthrough versus, hey, we have stuff that works, let's get it out there and make it cheaper?
Yeah, that's a great question, and the way I view this, and in fact, I was just a few weeks ago at the Clean Energy Ministerial, and we talked about it with energy ministers really across the world. Primarily is what's the role of government in this arena, but it spoke to your question. And the question, I think here's the framework that I would add. There's kind of three segments of the ecosystem of research. There's a basic research part. Government has a clear role because they're primarily the only funder of real basic research, breakthrough kinds of things, and I think that's where you've got to continue to prime the pump. On the far end of that is the commercialization part, where you're essentially taking things to market. There, the private sector has the major role. If there's going to be a government role, it's got to be with standards, it's got to be with resource assessment, it's got to do with harmonization, intellectual property, trade, those kinds of things. I think that's where government plays an important role. That piece
a lot of what government does at that stage is try to regulate everything, and then they stop it.
and that one, so we can make we have a couple of bad examples of what government can do. In the middle is the hardest piece, which is that applied research. How much breakthrough do you offer, and what's the government role in that? And I think there, I'm a big fan of pre-commercial competitive kinds of things where all of the industry partners come together and platforms for how they might all benefit, but then they compete within that context. So, I'm a big fan of public-private partnerships where consortia come together and use the government resources, the government labs, others to help raise the competitive posture of a particular company or country rather, or platform of a technology. But I think you got to be cautious in that area. So this is where the debate normally occurs. But I think there's a role in all of these. It's just a matter of it changes. And we need to be at least recognizing which one of those pieces are we talking about. And I think Secretary Schultz said it right earlier. On the basic research side, I think we have great bipartisan support that research is important and we need to invest in research. And so that one is less controversial. The others are more challenging.
Last question.
Hi. Yeah, I've been hearing about the insurance idea for about 7, 8 years now, and it's very appealing. It really is. We do take that. But then I look at it, what have we done? And it seems to be not commensurate with what the need is. And I think there may be some lessons here also from some other insurance examples. We all, as homeowners, take fire insurance. But even in the Bay Area, I don't think many of us take earthquake insurance. And I think the reason is that the anticipated payouts after deductibles and after all the premiums, et cetera, are not commensurate. At least that's the impression. That's why even the California Earthquake Insurance Agency doesn't promote it very heavily, it looks like. Is that the case here? Is it too little too late coming up? Is that why we are seeing this sluggishness? You showed the great increase, more invested in terms of the investments going in for renewable energies, the new wind and solar, and getting in more than coal and natural gas. Of course, what you showed were the gigawatts, but not the gigawatt hours or terawatt hours they would have produced that year. So with all that extra thing, is it getting there fast enough? Or are we too little too late?
Well, I'll start. I'm sure Secretary Schultz has some ideas about this. I would say the following, is first of all, we're not moving fast enough if we care about the amount of carbon emissions in our atmosphere. We're not moving fast enough. All the results, all of the projections, even at some of these very, very hefty sorts of deployment targets. And by the way, the numbers that I gave in terms of the percent, those are generation numbers. Those are kilowatt hours. Those are not kilowatts. Those are kilowatt hours of actual generation that's included in the proportion of renewables for those various countries. However, we do need a burning platform to kind of move the ball much more quickly. I've said frequently, we're pretty good at crisis management. We are not very good at preventive medicine. And this falls in the category of somewhat preventive medicine until somebody recognizes that, gosh, this is a catastrophe and I'm personally affected today, or my children will be affected tomorrow. And I think we're quickly getting to that point. So the burning platform is starting to get a little warmer these days. However, I think we don't have the sense of urgency. I think that's the biggest gap. I think there is a progression in terms of investment. I mean, and we have this debate in this country at a much different level than you see that debate in other countries. If you go to Europe or you go to Asia, they don't have this debate. They're already on board with this notion that carbon is important and we're going to start to mitigate it. There's fewer countries today, but the U.S. is one of them that has essentially less or more resistance than I think the rest of the world. So I find that a bit frustrating because we should be an enlightened people and we have the tools and the capability to be competitive on a global scale if we would just move out. And I don't think we're going to make a sacrifice even in the short term to do this. I think there are ways that we can do it prudently without making the sacrifices. But we have to have a will to do it. And right now, we're more entrenched and we're more comfortable than we need to be, I think, in terms of the challenge of the problem that's in front of us.
Let me give you a little different answer. There are problems in this country. We are working at them hard, and you mentioned Europe. We all recognize that if you don't get the developing countries on board, the Chinas, the Indians, you're not going to get there. And they're not really on board. How do we do that? Let me tell you how we did it in the case of the ozone layer. Let's stop talking about what you can do by 2050. Anybody can agree to anything on that. What can you do today? So if I were in charge, I would have a meeting with my Chinese friends and say, let's get intellectual property business squared away. And now let's figure out everything we can do today and start doing it. Have a doer attitude. And pretty soon things will begin to work better. That'll catch on, and other countries will want to get in on the game. Will say, come on, the water's fine. And you spread it. In the Montreal Protocol case, what happened was DuPont came up with something you could do, and we managed to get it all around the world. The countries that were poorer, we provided a little money to have that happen. And before long, we had the Montreal Protocol. And it wasn't that long. And I think in looking back, the scientists who were worried were right. And the Montreal Protocol came along just in time. So I think we better get busy as doers. That's what we're known as in the end. We're doers. And we've got a lot of stuff to do with, and we should go and do it.
That's a great place to start.
Thank you all.
Thank you.